film, just please ignore the camera. Yep.
Oh, sorry, I was in the corner.
That's not ignoring the camera.
Your fat body is covering. Yes, that is a fact.
Okay. Evals all turned in. Dylan?
Sure.
Close?
Yeah.
Like I said just a couple minutes ago, today is one of the most important days of the whole semester. We all have the engine basically torn apart, correct? Most of it is clean, correct? If it's not cleaned, we need to get on that, maybe come in after school a little bit and work on it, okay? Now, how do we tell if our engine is in good shape or not? The parts all look pretty much okay, except for your rod that broke, and your crankshaft that's kind of damaged, but everybody else's parts all look pretty good, right? Carter's looks great, Declan's looks great, your valve's kind of bent on yours. But how do we tell if something's worn out or not? If the threads are gone, that would be one way to tell that maybe a bolt or something is bad. Not smooth. If we feel in here and feel it's not smooth, absolutely. Maybe there's a big ridge at the top of our cylinder. Okay. The best way to tell if something's worn out or not is to measure it. So we're going to start measuring. Now, Carter, you're in my forestry class.
Yes.
How did we measure trees the other day?
With a metal thing.
Metal thing?
Oh, the beating stick.
Not beating stick, Biltmore stick. In the box, please don't.
Yeah, beating stick. And a
A
tape
Biltmore
measure.
stick and a tape measure.
No, not a tape measure. Like tape.
It was like tape measure.
And you know when you look through?
Yeah. Do you think you could measure a piston
I can make
or
that thing with a
a
Biltmore.
valve or any of that stuff with a Biltmore stick or a tape measure?
I can make that tape measure.
Probably couldn't take it.
Could you do it very accurately?
Absolutely not.
Absolutely not. Why
With
not?
a tape measure, you can.
Okay, maybe with a tape measure would be good.
A ruler.
Not really.
A ruler would
Then
be
you have
better.
to measure every dimension.
You couldn't measure it accurately because it's not meant for engine parts, it's meant for trees.
Not meant for engine parts, meant for trees, absolutely. So we have some specialized
Beating stick.
measuring tools that we're going to talk about today, and that's our first objective today, measuring tool identification. So my hand here is the first tool I want to talk about.
Field gauge.
It's a feeler gauge. Absolutely right. What do you think these are used to measure? Dylan, take some notes, please. So what do those look like to you guys? Okay, what do they look like, Declan? Describe them to me. You don't know?
Yeah, little.
Just feel that one right there.
Chinese.
What's it feel like?
I think something's in the way of your camera.
Feels like metal. Is it thin, thick,
Thin.
flexible at all? Maybe a little bit.
A little bit.
Okay. These are used to measure clearance between two items.
So how many of those you can fit between it?
So the distance between two items. You can feel it. Okay, be careful. These are precision tools. Okay. Each one has a specific measurement. This one that I'm holding, this very first one, says 0.0025. It's not a centimeter. This is all in English measurements, so inches. Okay. So let's review decimal points real quick.
0.002? Can we say?
So if I start with
2,000.
0.1, what is that?
100.
A tenth. This is a tenth.
100.
What's this? 0,
100.
100, 100, and
1,000.
1,000. Absolutely. So about the farthest that we're ever going to go for our purposes is 10,000.
10,000
Mhm. Most of the time, we're just going to go to thousands. Okay? Thousands. TH at the end of it, yep. Okay, so like this one here, it says 0.0025. So, how many thousandths is that? 0.0025.
That's 2,500.
2 thousandths. The way that I would say it and the way that we will say it in this class, 2.5 thousandths. Okay? So 0.0025, that would be 2.5,
Right, that's how
Thousand.
thick it is from here to here.
and that's how
Oh,
thick
thin
this
from-
piece of metal is. Look how thin that is. That's pretty dang thin. So we need to be accurate down to 1,000th of an inch. So that's why we have these paper thin measuring tools, these super accurate measuring tools. Okay? Where do we want to use a feeler gauge? Do you have any ideas?
I have no clue.
No clue. Anybody else have a clue?
In between, or where do you put the rings in?
Want to put the rings in on the pistons? Absolutely. So the ring, you remember it had a gap? When we squeeze it together, we would measure the distance between those rings with a feeler gauge. Also just the piston clearance between the bore, we could use a feeler gauge on to see how many thousandths of an inch are between the piston and the cylinder wall. We want it to be pretty tight, not so tight that it can't move, but not so loose that it just doesn't have any compression. Right? So we got to use these precision measuring tools. These are feeler gauges. We use them multiple times throughout the semester. Okay? So you know what a feeler gauge is, you know what it looks like. We'll come back to that. Now, in engines, we have other things that we need to measure. What are some of those other things that we need to measure? What do you think, Declan? What was that? Okay, we could use a caliper to measure like what? Piston. Anything that's fairly large that we want to know like the diameter or something, we could use a caliper. And we'll come back to calipers. This is going to be, I have a PowerPoint on calipers. Good job, Dylan. I'm thinking of a couple other things that we want to measure. Not with a tape measure, not with a caliper. Just what's something on this engine that we would want to measure? Depth of what? Maybe with the valve seats, yeah. The main thing I'm thinking of right now, the cylinder, what shape is that?
Circle.
The circle. Distance across the circle is what measurement?
Diameter.
The diameter, okay? We need some tools to measure the diameter of this cylinder. A caliper can go backwards, but do you think it's going to be very accurate? Can we get very far down in there with a caliper? So take a look at our caliper. It just has a couple blades. How far down in there could that thing go?
No, I mean.
Yeah, but you raised a good point. How far down in there could that go? Maybe. As far, like this part that can spread apart, how far down there could that go?
Like not very.
Just as far as this blade. Just as far as this blade, actually, the small one. So we're only looking at like a ½ inch.
So that's used to measure the diameter
So this is used to measure diameters of things such as the crankshaft that's worn out, or the camshaft that's worn out. Like I said, we're coming right back to calipers. We have some tools to measure holes, like the cylinder. This is called a telescoping gauge. There's a whole bunch of different sizes. It looks like a T. I've heard them called T gauges. They call them a telescoping gauge. Now, why do you think it's called a telescoping gauge? These arms are spring-loaded and they move back and forth. Okay? On the bottom, or top, whichever way you hold it, there's a lock. I can lock those springs in a position. I can lock those telescoping arms in a position. And so this is used like in this cylinder. I would get it kind of compressed, put it down in there, let it go, and I would get it straight up and down, and I would lock that, pull the gauge out. Then I can use a caliper, like Dylan said, to measure this distance. And that's going to be our diameter, or the size of our hole. Okay? Yeah, Carter?
Like measure like everything on that answer?
Everything.
Really?
It's a long process.
Okay, so is there like paper that you give us that say?
Yep, I have a paper that shows every part that we need to measure,
And you write down.
and you write down the measurements.
Why? What's the point of that?
What is the point of that, Carter?
To see if stuff is worn.
To see if stuff's worn out. We don't want to put an engine back together that's totally worn out. I'll use my engine as an example. One time when I was in college, I took an engine up to work on in my small engines class that trained me for teaching this. Now it ran pretty good. And when I took it apart, it all looked pretty good. But this engine had a lot of hours on it, and it ran in the dirt quite a bit. And so the cylinder was worn out almost 20 thousandths over what it should be. Now, that doesn't sound like a lot, but in engine size, it's huge. 20 thousandths is huge.
So what did you do with it? Garbage?
So, no, it wasn't garbage. I knew then that it would either be garbage or I could do something to fix it. I could make that hole bigger so it's the same size everywhere. Get a bigger piston that would fit that hole, and now that engine runs better than new. It's absolutely what we're talking about, boring out like a small block Chevy or something.
So, if you bore it out, would that give it more horsepower?
Fractional amount of more horsepower. Okay? So that's why measuring is important, Carter. Something may not look worn out, something may run and not act like it's worn out, but really it is. Okay? So telescoping gauges can help us find diameters of holes. We have all kinds of different sizes. You can see that was kind of a medium-sized one. We have a really big one for some of your bigger engines. And they have huge sets for really big, like diesel engines. In this same set, there's also a little tiny one. A little tiny one that we can use to measure some pretty small holes. See those telescoping arms? They're pretty close together. It's a cute little guy, isn't it? The telescoping gauges, all different sizes for all different sized holes. Okay? But holes like where our valve stem come up, or where our points plunger is, if we have an engine that had points. Did any of you have engines that had ignition points on them? I don't think I saw any of them. Okay, so some of these really tiny holes, like we use the valve guide, Carter.
I was playing with Carter.
Yeah, let's put it away, please. This won't fit in there. Even though it's tiny, it still won't fit in there. So, what do I do in that situation?
They're little. It's like little. It's just like circles. Until you find that makes sense.
Little circles that you put in and it fits till you test it till it gets snug?
Yeah,
Not quite what I'm looking for.
exactly.
Any other ideas? Tapered rod, maybe, but would that be very accurate? Not really. Dylan, do you have any thoughts? The holes where the valves go through, yes.
Just the tiny little ones?
Tiny little holes, yeah.
Can't you just use the caliper on the cylinders itself, like,
The caliper on the valve, you mean?
you have a valve?
Okay, you could do that, but what would be the problem there?
Wouldn't be very accurate,
Why not, Carter?
because you can't get it.
Okay, so if we just measured the valve, what could happen to that valve, Spencer?
Well, the valve could be skinnier than the cylinder, because the cylinder could be worn.
The valve could be worn out, and the hole where the valve goes could be worn out. So that wouldn't be too accurate. It's a good thought. It's an excellent thought. And the measurement of the valve stem is important, but it's not quite how we measure that hole. We actually have something called small hole gauge, for those really small holes. So this is what Carter was talking about. It has a little ball on the end.
I told you that exactly.
It's exactly what you're talking about, yep. It has a little ball on the end. Go ahead and take a look at that. Have you heard of these? Maybe seen them somewhere? Has a little ball on the end. All the way from this size down to really tiny. We got, buddy, babies. We got small gauges. So these come in all different sizes. All. Okay, you don't get it. How does it work? So it just has a ball on the end. How does it work though, Carter?
Put it in the hole.
Okay, you put it in the hole,
Put the ball in the hole.
but then what?
Then
You go back
you
and
measure
forth
the ball.
until you find when it's snug.
So the ball is on a little screw, and there's a little tapered piece. Did you notice that tapered piece when I was bringing it around?
Yeah.
So as we tighten this screw, the tapered piece goes in, it spreads that ball apart. The ball goes out, touches the sides of whatever small hole we're trying to measure. We get it to where it's snug, just like with the telescoping gauge. Then we can pull the ball out and measure it with our calipers. Okay? These tools don't have any like numbers on them. They don't have any scale. They don't have any way to just show us what that measurement is, do they?
Check the caliper.
So we have to check it with caliper. Caliper is our most crucial piece of measuring equipment that we use in our shop.
Like every, like, all the bolts go in.
Not the bolt holes, not quite, no. Okay. Now we're going to start talking about dial calipers. And how do we use it? Has anybody ever used a dial caliper before? Camden and Connor,
Justin has.
Declan and Spencer. How do they work, guys? There's a dial on them. What does the dial do?
How'd you do that?
Yeah, no kid, Nick. I haven't measured anything, I just played with them.
You just played with them? You haven't actually measured anything? Okay. So dial caliper, as Spencer said, it has a dial on it. It also has some numbers on the side there, as you can see in that picture. Everybody see that? Okay?
Yeah.
All right. So they're pretty common. Almost every shop you go into, especially like an engine shop, will have dial calipers in it. Up at the university, we use something called a micrometer. Maybe you've heard of a micrometer. It's a horseshoe shaped. It does essentially the same thing. Measures the distance between 2 points. The caliper would measure between this surface and this surface, or this surface and this surface. Now a micrometer measures between 2 surfaces as well. Okay? Our shop here uses calipers because it's most likely what you're going to be using later in life. Plus, they're a little bit simpler to handle. Calipers you have to, micrometers you have to hold a little bit weird, kind of with your pinky, and they're really tricky to read. Okay? Make sure we're taking notes on calipers, guys. This is going to be critical. Okay, dial calipers can be used to perform 4 common measurements on parts. outside diameter, inside diameter. The outside diameter might also be the thickness of an object. Inside diameter would be the width between a space, like our cylinder. We can measure that inside diameter. The next two we're not quite as worried about with our calipers because we have some of those other tools. The step distance, oops, and the hole depth. But they can certainly measure those two things. Okay, on our caliper, we have outside measuring faces. These are the faces that we measure the diameter of something. So like our crankshaft, something round, like our piston. We can spread the caliper out, clamp it down on that surface between the two blades and get our measurement, okay? That's what the two longer ears are for. Where is it? With outside measuring faces. Outside diameter of an object. It can be round, it can be square. As long as we can get it between these two surfaces, we'll be alright. We can measure. Inside measuring faces. These are these little ones on the top of the caliper, the little ears. They can measure inside diameter like a slot or like a hole in a washer, potentially the top of that cylinder. We couldn't get very far down in there, but if we just want to measure the very top, I can certainly do that. I can stand this up, spread the caliper out, and that would give me that distance. Okay? It's a pretty handy tool. Questions so far? Declan, question? Alright. So again, inside measuring, small holes. Carter, stay with me, bud. My computer did? Yeah, it's just trying to get on the internet. Camden, don't stare at my camera. Okay, these spaces, a step measuring space, between which step parallel surfaces can be measured. So if we had a step, like if we had a piece of metal that had a ledge going out, and then a step down to another flat ledge, we can measure that using a caliper. I'll show you that here in a minute. Just like that. So we can measure, set the bottom of it flat on the bottom ledge, and then measure up however far that step is. We could use a ruler, but this is by far more accurate. Something big, if you want it to be ballpark, absolutely. No. We'll use calipers for everything. Good question. And finally, maybe you noticed, this little part slides out on the end here. We use that for measuring depth of a hole. So if you have a bolt hole that this will fit in, you can measure how deep that bolt hole is. Stay with me, Carter. Just like that. With this end here, yeah. See how that part slides out there? Slides out. all those functions, Carter, record.
Remember, this is on camera.
All
Yeah,
those,
whatever you said.
all those functions from one simple tool. That's pretty amazing. So we know this thing has numbers on it. We know it has a dial on it. But how do you read the thing? How do you read it? How do you know what the measurement is?
You learn about it in class.
Can I see it?
The dial's thousandths, absolutely. And we're going to talk about that here. Okay, a standard inch dial caliper, which is what we use. We don't believe in metric. This is still American engines where they use the American sizes. It will measure slightly more than 6 inches. Declan, that one just over 6 inches long?
Yep.
Okay. Blade scale, if I can have that back, please.
Can I play with one?
In a minute. Look forward, please. The blade scale shows each inch divided in 10 increments. Each increment equals 100 thousandths. What is 100 thousandths? 1/10. So on our caliper, if we look, there's 1 inch. In between that inch, there's going to be 10 numbers. 10 lines. It's going to be tenths of an inch. Okay? But we said that for our purposes, we want to measure to what increment? Thousandths most of the time. So how do we do that? The dial. So the blade, the part that comes out to measure our deep hole, it doesn't move. Actually, no. The blade is the backing part. The part that moves is our moving part. The blade is the backing part. The part that has the numbers on it. Okay? It's been precision made so it's accurate. The slider is the part that has the dial on it. The part that has the part to come out to measure the hole. That's called our slider. Slider moves along the blade, used to adjust the distance between the measuring surfaces. Okay? There's a pointer on our dial, kind of like a watch. Rotates within the dial as the slider moves back and forth along the blade. Dylan, when I move this, does that dial move? Which way is it going? Clockwise, if I move it back together, counterclockwise until it gets to 0. And you'll all get a chance to play with these in just a couple minutes. They also make digital calipers. If you're willing to spend just a little more money, they make digital calipers and they can be very accurate. I wouldn't recommend like a Harbor Freight digital caliper. Might not be the most accurate, especially for like engine work.
Don't recommend the gloves either.
I don't recommend much from Harbor Freight unless
You
you need a
recommend
throwaway
anything?
wrench. If you need a throwaway wrench or something, fine. Something to keep in your pickup and get all rusty, fine. As far as precision tools,
That
not
sounds
really.
more like a club used for house events.
The reference edge. So how do we read our numbers? There's an edge, and that arrow is pointing to it. It lines up with those notches. Lines up those number lines. Okay? There's a toothed gear on the back that we can roll with our thumb. We can use that to make some measurements. Carter, stay with me.
Yes, sir.
I can't wait to get these in your hands so you can actually see them, touch them, feel them. But now we're to reading it. The nuts and bolts. How do we read it? How do we get an accurate measurement? Dial divided 100 times. It goes from 0 up to 100. There's no 100 shown. It goes 0 up to 90 and then back to 0. So it's 100 scale. So that means that each mark on that dial is how much? It's 1/1000 of an inch.
So, are the dots the thousandths, or the lines, or a mix of both, or what?
The lines.
The dots are 10,000.
Our dials don't have these dots. Okay? The lines are what we're looking at. And those are the thousandth marks. Okay? Good question. And you'll see once you get it in your hand. Every time the pointer goes one rotation, the reference edge on the slider will have moved the distance of the blade scale increment of 1/10 of an inch. So each dial mark is how much? No, each dial mark.
Oh,
Not 10.
It's hundreds.
Not 100.
No, it's a major one.
10,000.
It's 1,000.
Oh.
1,000. Don't said it. I want to get it out of more of you. It's 1,000.
I thought you
So if we go around one whole revolution, it goes around 100 thousandths. 100 thousandths also it equals how much? 1/10. Okay? You didn't know you were in math class, did you?
I do. I have a hand. My brain.
Dylan. Yes. Okay, so every time that pointer goes around one revolution, we've moved 100 thousandths or 1/10 of an inch. We're close, Carter. So this is just going through the motions. Now we've moved half the way across that dial,
So with that,
3/4 of the way around that dial. What would that measurement be?
6,
75.
75 what, Carter?
Hundreds.
75 hundredths?
75 tens.
Not tenths. What would the number be?
6.7.
7.5 tens.
7.5 tenths? No. Has it gone all the way around? Yeah.
Duh.
No.
Wait.
We started at 0.
Up to the phone.
Oh,
Start here.
7,500.
0.075.
So it would be on this one,
7,500.
not 75, look where we are.
2,500.
25,
Thousand.
or, okay, the way I would say that is 2.5 thousand. The number,
Wait,
set this down,
would that be thousandths or hundredths?
thousand. Remember, each mark on the dial is 1,000. Remember? So right now, let's go back one slide. Right now we're sitting at what number?
6.
Straight up, 0.
6.
Okay, so 6, but let's just focus on the dial right now. What number are we sitting at? 0.
A little above.
So what would our decimal be?
0.00001.
It would be point zero, how many zeros?
0, 0, 0. 2 more zeros. and
3 zeros.
And
Is it
then
measured
then
in?
1 after that. You can tell it's 0 and 1.
Okay, so we're just gonna pretend it's exactly on 0. So it's at 0. We go forward, oops,
We're done.
we go forward. Now what does that thing say?
2.5 thousand.
2.5 thousandths. So our number would be
Point
point zero what?
0.25.
0.0025. Remember, this is the thousandth place. This is the 10,000th. So we would call that 2.5 thousandths. Okay, so if we're like in between there, you're saying it would be like 2.3 thousandths or 2.2 thousandths is the way we say it. Okay. Because Because it was Case versus John Deere day, so.
John Deere, right?
I like Case. Everybody has their own opinion. Okay, so now we're going around this dial a little more. Now it's sitting at 50 on the dial. 5,000. 0.005. 5 thousandths. Okay? So Carter, back to the 75. What does that one mean? 7.5 thousandths. So how would I write that?
0.0075.
0075. Absolutely. You guys are getting this. And if I go back to that 0, now we've done one revolution, what would our number be, Declan?
7.0.
We've gone one whole revolution.
Oh, it'd be 10th of an inch?
It'd be a 1/10 of an inch. Or how many thousandths?
Wait, a 10, it'd be 100,000?
100 thousandths or a 1/10 of an inch.
That's actually 7 exactly.
Or we would be at 7 inches. Or 7/10 of an inch. Because that hasn't hit the inch yet. So that would be 7/10 of an inch if we were looking at that slide. Right now I'm just focusing on the dial. Okay? So now we're going to start talking about the inches on that scale. To determine the outside diameter of this pipe section, the user must first identify how many inches are being shown on the blade scale. Up here on the blade scale, how many inches do you see there? Get closer if you need to. How many inches are being shown up here? Did everybody see that? Get a little closer if you need to, yes.
1 inch and 47 thousandths.
Okay, so I'll stop you at the 1 inch. Right there, that big 1 inch. Okay? So our starting point is going to be 1 inch. So we write a 1 on the left side of the decimal point. Declan,
Yes.
what's our next number?
Say that again?
So our reference edge is located between the 1 and 2 inch marks, so the user makes a mental note of 1 inch. So I wrote down 1 inch on the board. Okay. Get closer if you need to. It's really hard to see from back here. So I make a note of 1 inch.
1.4037.
Now we have to decide how many of those 10th marks there are. In this case, it gives you how many? How many of these 10th marks after this 1 inch?
So where it's at right now?
Yep.
14.
14. So from this 1, how many do you see past that 1? 4? Absolutely.
4.5.
Okay? So I'm going to make a note of 4.
037.
There are 4 whole 10th lines shown. Okay?
1.4037.
But I want you to see how we do this. So we could say point something. But all we know for sure right now is that we have 1 inch shown, and after the 1 inch we have 4 shown. Then what do we do?
You got it. You gauge.
Next, the user looks at the pointer on the dial to see how many thousandths it is pointing to. So Anna, how many thousandths is that pointing to? Sitting on 37, roughly. Yeah, 37. That gives us 37. So how would I write that?
1.437.
1.437. So you can see over here, if we wanted to show our math, we started with the 1 inch mark. Then we found the 4 tenth marks. And then we found 0.037 on the dial. We add the 3 values together, 1.437 inches. Okay, how wide is this block, guys? Go up there, take a look at the screen a little closer. Go ahead, Dylan. Go up to the screen and take a look at that.
Right?
Go ahead and take a look at that, Dylan.
1.403.
Don't give him the answer yet. How many inches do you see there first? We see 1 inch first, then what?
1.402.
Okay, so there's 4/10 marks being shown. How many thousandths do you see there, Dylan? 2. So how would I write that? 0.2. 1.402 inches. 1 inch, 402 thousandths. 1 inch plus the 4 plus the 0.002. 1.402. We made it through Caliper Basics 101. Now, I have a couple things for you to practice measuring. Okay, so we're all going to split up a little bit, share everything. I have some stuff scattered. There's a bolt in front of Miss Hall, a bolt over here, a washer over here. There's a piston here. Calm down, guys. Piston back here. I've got some calipers in these boxes. I want you guys to practice measuring. And you can go ahead and close that, Mr. Ford.
Where are we going now?
Sure.
I stole the water.
Okay.
And 90s, right?
1.696. Let me take a look. Let's see, 1 inch. 6, because I can't really see that 7 line, good. And 9, 6.
What do you do if it's not on 0?
If it's not on 0, when you start,
Yeah.
I think you might have that one funky one. It's like an 1/8 of a thousand off. That's not going to hurt us too much.
An eighth of a thousand. I felt like 20,000.
That makes me mad.
For practice purpose, that one will be all right. Hey, Declan, Chayton, go ahead and grab a caliper. See if you can find something. You can measure something.
Like it's are you trying to hurt me, Cody?
My chair over here.
Send it back to me so I can get the sandwiches.
Carter,
No, no. Like her
Alright.
texting.
may I see that?
Thanks.
May I see it for a second? Miss Paul, what's the diameter of this rod?
You don't know what we're talking about.
I don't want to know what you're talking about. Let's focus on measurements. Go ahead and take a look at the feeler gauges, the telescoping gauges, the hole gauges. I have another caliper here if you'd like. Share, Carter. Sharing is a virtue.
Sharing is caring.
Sharing is caring.
Let's have a.
Questions about those?
Oh, that would be so much.
Take a look at it.
This is not.
So look at the thinnest one. See what it is. And then look at the
Oh,
thickest
you just stand
one. That one.
This one doesn't have the right size to do this.
It doesn't have the right size to do that?
Oh, yeah. Point 0, 0, 0.
Okay, actually, no,
Oh,
zero.
0.005. I don't think. Watch your mouth, Carter.
Big one.
Gentle with the telescope. Gentle.
Don't point it.
0.024.
Get to me now.
We have almost a quarter inch worth of feeder gauges. lots of bent and ruined feeler gauges because students tend to just bend them, and so feeler gauge. That's a telescoping gauge, remember? Feeler gauge is, if I could see that for a moment, please. These are the feeler gauges.
Okay, like that. And then-
No, I don't bend them.
You have the bigger caliper?
Hey guys, go ahead and take a look at the feeler gauges too, they're pretty cool. Be careful with them, they'll bend.
Yeah, the same color shoes.
So what's the measurement on the top of that?
This one's special. Two?
Gentle, that one, gentle. How much?
Okay,
A bigger caliper?
What? 2.7,
Can't really
2,
measure that.
3 is absolutely correct.
that's like for the tinfoil.
Alright, go to your turn, measure something else.
Make sure we get lots of practice with these. Did you figure it out, Anna?
Let's see how big that is.
Show me how you did it.
Oh my gosh.
Carter, careful with those feeler gauges.
Isn't that feeler gauge?
Can you see the whole line on that 4? Okay, so it would be the 3.
Let's check.
Hey guys, make sure we're practicing.
We are.
Two is what I would call that.
Oh, good.
Okay, let's see here.
3 7.
3 coins. No, it's
We have to
2.
make sure we can see that whole line. How are you guys doing?
9 and 5.
Come on, guys, real quick.
Yeah.
Side of it now.
This.
2.995, okay.
1 inch, 1
Gentle guys, these are precision tools. We don't want to hurt them.
980 gentle.
Be very gentle.
I'm gonna measure one of these feeler gauges.
You're gonna measure one of the feeler gauges and see if it's accurate? That would be a good thing to do. So we can absolutely measure the inside of that. We can measure our
Whoops.
pinhole.
Okay, let's see here.
No.
Got it figured out.
Hi, Brad.
So why don't you measure the length of that bolt for me? Yes, sir.
Let's see that.
Jamie always does that.
Whichever one is closest to the
It's the door.
So let's just say, for example, that we were like right there. That looks like it's closest to the 7 to me.
Okay.
It's kind of a judgment
Maybe
call.
just hold it here.
Okay.
That makes sense. I was just,
Yeah.
it's right here. Right. A little bit, like right here. I wasn't sure.
If we can get as close as possible, we'll be okay. We can practice with the small hole gauges like Carter's doing. That's great.
Hey, I want to tell you what it is.
Make sure we're practicing, because next time I'm gonna have some things laid out, and I will know the measurements on them, and it'll be a little quiz to see how you can measure.
Mr. Jones?
Yes. Hang on, Declan, I'll be right there.
Work on tips for safer selfies.
I can just barely see that 7 line, so I would go 6.
What is this?
2, 4, 3, is that correct?
I'm so smart at this. Everybody else is
So it would be 1.6, and then whatever the dial is.
Yeah, the quiz key.
Which part?
1.5. It may have moved. Are they accurate, Declan?
Oh,
I'm gonna
Yes,
say
proceed.
8.
Well, okay, so here.
Okay.
It's a white.
I've been taking quite a bit lately, so no judging.
So use this little thumb wheel, and it'll be much more accurate. We also want to make sure to make straight. There's lots of things that can make our measurements not accurate.
So that is
I need the big.
How many inches do you see?
2.
You got
and
it.
I'm
gonna go for a walk.
And then our dial will be our thousands. So 2.6 what?
Uh-oh.
7.
No, 6. It's
joke.
I'm sure it was, this one's broken.
Yeah,
What's up?
There, here's two.
really?
Are they rounded off and it won't?
Are you
serious?
Oil.
So we might be able to use a big small hole gauge on that.
Oh.
Or we could probably use our caliper on it.
There, there's a 7.
Okay.
How far did
Don't
you
squeeze
squeeze
too hard. No, every.
Are you
rotation-
kidding?
How far did you have to zoom?
Oh.
100,000.
How far did you
So
have
it's
to
a
zoom
10. Carter, Dylan,
Well, I would
keep practicing, please.
I already practiced, you know I'm the best one here.
I know you're doing very well,
Oh,
but let's not get cocky.
it won't come
Oh,
out.
I'm the best one here.
I'm the best there's
Legit
ever been,
getting
that's.
cocky.
Okay, Anna.
Carter.
Carter.
Carter. I'm the best there's ever been, I wake up in the morning.
I say so.
It's not gonna
Best there is.
What are you doing?
I wake up every morning. I feel excellent.
Carter, watch your mouth.
Space isn't a bad.
What did he say?
Carter.
Carter. What do you
You
want?
took 130.
Uh-oh.
2 verses.
Oh, did he just hold it?
Okay. We can be using some of those small hole gauges. Gentle with them.
Dude, Declan, you
Right
could
here.
say he didn't zoom in.
Right there. And then-
Spring shut out. Okay, be gentle with them.
Yes, bro.
I would have too. Dude, come over here.
How many full lines
What
there
would
do
you
you
have
see on
done?
that?
I'm gonna put it in my screensaver.
You would have what to it?
Or hits.
I would have.
And our dial.
I would have like this to it.
Okay, so what would our total number be?
That your screensaver trying to take a big cock.
Yeah, but he didn't zoom in, so he's
It was dark in there, okay?
It was dark.
It was dark. I turned the flash on, but I picked it up too fast.
Okay, so.
That's
We have 0.4 correct.
It was freezing out there.
This
It was
is
70
numbers
degrees.
After, so let's see.
He meant to film.
So right now, they're sitting at 1.
I was attempting a front flip.
7, 4. This is our hundreds. So you were correct, yeah.
See, this is how it's supposed to look, not like you did it.
Mr. Bryant.
I'll be right back.
Shane, we got problems.
What's up? Oh, we broke a ring.
Yeah, I pulled it too hard.
That's alright, it's just a.
Chain goes like this.
I came sideways. Landed on my hand. And it's rolled.
I was like, oh, yeah. I just changed the eye.
Gentlemen, how you doing?
Great, Mr. Jones.
Ready to pass that measuring quiz next time?
We're doing,
So fine.
100% guaranteed.
and I want to say
I have
100%.
one question and I'm good.
Okay, what's your one question?
So when you got the inches down and then the hundreds down,
Yes.
then it's the thousands.
Then it's the hundredths, and then it's the thousands. Come here. We'll show you. So each of these numbers on the dial is how much. Gentle with the telescoping gauges, guys.
Hey, come here. Over here.
I'm gonna Pomerel for the last.
These numbers here,
I want to try to get it. Stay in hold of it.
these numbers here, are how much, Declan?
That'll be a couple weeks.
Because
100.
Hey,
Thousands.
Declan,
You hold that.
when's your race? In Targhee. When's your race in Targhee?
Like I said, we don't have this.
That hurts, it's sensitive.
Okay, hold on, I'll show you. I gotta look at my schedule.
Mr. Jones, Dylan's trying to laser mine, now I can't see.
Hey.
Dylan, lay it down.
Hey, he's trying to
Oh.
send it to the office right
Okay, Carter, come here.
now. No, send it to the office. He's doing it again.
Yeah, I'll
Send it
see
to
you.
the office.
Okay, Dylan,
So,
please don't.
Hey, can I keep breaking this?
I'm gonna draw a caliper,
Alright,
okay?
we're gonna do an
So,
experiment.
Here's
Yeah,
that.
Myself.
Carter, hang on.
That.
I'm trying to show Declan something. Okay.
This is for beating kids.
Yeah.
Hundreds of thousands, and then you go
Right.
2 inches, 2
So let's measure where that is right now. You see how many inches?
Okay, 2.
You see 2 inches.
Alright.
Carter, please erase that. You see 2 full inches. How many tenths do you see, guys?
Shane's dead.
Right.
Carter, no rough housing.
Back.
Do I, is it 7?
How many tenths do you see?
Money.
Can you see that whole line on that?
I see you
Okay.
You look
So
like
5 is our 10th place.
Why do you need to hear?
Because I keep an eye on you and you can help. Carter, get back here. Sit there. Okay.
Shut up. Obey.
Dylan. Okay. We have our tenths written down. Now we need to figure out our thousands.
You're so sheltered, Cody.
7,000.
I could be
So how
like
do we
that.
write that?
Chips for take, for shake, someone mark.
So, 0. What is 0 going in? That's the hundredths.
It's hilarious.
We got
because
seven,
it's front,
one
because
thousand.
it like wants to come out but doesn't. Yes.
Measure
Everybody's
the
like,
diameter of the big end of this.
sounds like he's like cute.
Shameful
You
green
guys work on
tray.
that and write that down on the board.
If I'm not working,
You don't watch it.
and it's not my dad's weekend, then.
Right. So I specified the big thing.
But if I found the date, then I
Yeah.
can request for the day off.
It's in April.
It stays cold up to top. So we're gonna have like a 2 month break here, and then we're gonna get some more.
One more good one.
0.
I don't live with you.
Is it 0.8? Oh wait, is it 80?
Yeah, it's 80.
Okay. So where would the 8 go? It wouldn't go in the thousandth place.
go
Instagram.
No.
No.
Well, we would've got a cooler
It would
video
go in the
at the
hundredth
same
place.
time.
Guys, Dylan, knock it off.
So when does it go, okay, if it's before 10,
I should have Jamie go from the stage.
okay, so if it's
Because
like,
you have your mouth covered.
so
Dylan,
if it's before 10, then it'd be 0, then the number, or, and then if it's after 10, then it'd be, like if it's 10, then it'd be 1, 2, 1, 0.
so
Like if someone shoved it in while you're sleeping, just let her loose and then tighten her
because
pad.
it's not up to
Broke
the
up
10.
your mouth.
Okay, and then if it's after the 10,
If
then
after the 10, then it's 100.
So 100.
Nope.
Lost
10.
it.
Tenth, hundredths.
Hundreds and thousands are displayed here.
What are you doing?
So that's 70,000 or 700.
Makes sense.
Okay?
Isn't this class just?
Glad you're asking these questions.
Case, that's
Calm down, guys.
Chop!
I will remind you that video evidence of all
Oh my
this
goodness,
stuff
dude.
that's going on.
It just saw me do that.
So if I need Mr. Ward to tell him I have video evidence of everything that goes on.
Probably see it be like, oh, dude, that was so funny.
Yeah, that was hilarious.
We're practicing measuring, right?
Yeah.
We're ready to pass our quiz,
Right.
right?
See, we're
Yeah.
measuring my heights.
Yeah, see, I was like 5
See, look, I'm like high. Look how high I am.
Hey, don't break my telescoping game.
Leon's trying to keep sea level.
Visual with my telescoping game.
He shot me with his telescope.
Visual with the telescope. Guys, watch your mouth, put the bat down.
What are you doing, Cody? Why were you trying
Carter.
to shoot me?
Take a seat.
I really wanna hit
Don't
something.
move.
I don't
Rest of class.
appreciate it.
I need a.
Hey, Carter,
pencil.
stand right here.
You only need a marker
If I
wide.
get marked right, it's just.
Carter, kneel right here.
No, you're not drawing on the desk.
I'm not gonna.
I'm gonna eat me in.
Justin, how's the engine teardown going? Got it all put back together?
Nope, ran out last week, sorry.
You gotta put this down.
Anybody got it? Ready whenever.
I'd be curious.
Mr. Jones, no.
Dude, I'm
Holy crap.
This telescoping, whatever, is
Heated.
Do you still like
music practice?
Do you still like it? Okay, if we're done practicing measuring,
This one's done for.
are there any questions?
Carter started to break it, then Cody finished it up.
Hey, don't find out name of it.
If you guys do break the telescoping gauges, you are responsible for paying for
I
it.
think I didn't break it.
Got a handful of that cheese.
Next time, come prepared for measuring quiz. Dylan, leave my computer alone.
Okay.
Thank you.
Mr. Jones teaches us
I'm trying to see how
thank
far
people.
over you can. See, this right here is a blind spot, so see.
Okay,
we've been in the-
make sure my calipers get back in the boxes.
Oh, yeah, so they couldn't see whatever we did right here.
Make sure that the bolts, the piston,
Watch this. It's gonna be a big crush.
Last warning, are you going with Mr. Moore?
Lord Farquaad.
Next time, we are going to have a metric quiz. No notes, no friends, no nothing.
I don't have friends to begin with. I have fans.
By next time, I want all your engines clean, so if you have to come in after school, do it.
Oh.
We are starting to measure next time.
Tanner, we need to
Mine?
clean our engine. I guess my
Yeah.
engine's got it.
Excellent
I
job.
bet I can have it back
We'll
to
finish
the
it this time.
Okay, questions about measuring?
Can I have $20? I'll come in